let's move on to the pH scale and acid-base reactions. So the pH scale is a logarithmic scale describing the acidity or basicity of a solution. So if I have a solution with pH 2 and I'm trying to compare it to a solution with pH 3, the solution that's pH 2 has a acidity that it is 10 times more acidic than the pH 3 solution. If I have a solution with pH 2 and I'm trying to compare it to a solution with a pH of 4, then the pH 2 solution is 100 times more acidic. So it's not 2 times or 1 time more acidic, that doesn't make any sense. It's by a factor of 10. So the pH scale typically goes up to 14 and all the way down to 1, with 7 being neutral, 14, anything between 7 and 14, being basic, and anything between 7 and 1 being acidic. The closer we are to 1, the more acidic we are, and the closer we are to 14, the more basic we are. So pH can easily be calculated by taking the negative log of the H plus concentration. If you want to go backwards and you have the pH and you want to get the concentration of H plus, you just use this formula instead. So let's do an example. What is the pH of a solution that has 3.25 times 10 to the negative 13 moles per liter of H plus? So we're looking for the pH and we have the H plus concentration, so we're going to use this formula right here. So pH is equal to negative log of that, which gives us the pH as 12.5. So if we look over here, that's basic. Over here I put H plus, but we could have easily just put H3O plus, it's the same. So if the question gives you H3O plus, hydronium, you can just use that value instead of H plus. It's the same. So another equation you should be familiar with is POH. So POH is similar to pH, but instead of taking the log of H plus, we're going to take the negative log of OH minus. This is useful if you're given information about hydroxide, OH minus, but not H plus. So you can always convert by using this equation right here. POH plus pH equals 14. So if you're given the OH concentration, you can calculate the POH, plug it into this, get pH, and then calculate your H plus concentration. So now let's talk about neutralization reactions. So a neutralization reaction is a kind of double displacement reaction between an acid and a base. So it's called a neutralization reaction because the acidic properties of the acid are neutralized completely by the basic properties of the base, and vice versa. So in the end, you shouldn't have any acid or base. So if we're reacting an acid and a base, we should end up with a salt, so an ionic compound, and HOH, otherwise known as water. So the reason I'm writing it as HOH, and a lot of students choose to write it as HOH, is because this H over here will always come from the acid, and this OH from the base. So an example would be HCl with KOH, reacting to form KCl, which is an ionic compound, and HOH, otherwise known as water. If this makes you uncomfortable, you can always write it as HOH, and then at the end, erase it and write H2O. So let's do an example. If we have 25 mils of a sample of nitric acid, and it's completely neutralized by adding 32.8 mils of 0.116 molar sodium hydroxide, what was the concentration of nitric acid? So first off, we should write down the reaction right here. So nitric acid plus sodium hydroxide gives us sodium nitrate and HOH. HOH again is just water. I chose to write it like this because it's easier to understand. So first off, we need to find the moles of something. So we're given information to only be able to find the moles of sodium hydroxide at first. So the moles of sodium hydroxide, according to C equals N over V, just rearranged, will give us C times V. So when you work it out, you should get 0.00380 moles of sodium hydroxide. Because it's a 1-to-1 ratio between nitric acid and sodium hydroxide, we should also have 0.00380 moles of nitric acid. So now we calculate the concentration because we have the moles, and the question also gave us the volume. So plugging that in, note that you have to change the volume to liters, always keep it in liters. So we have 0.00380 moles divided by 0.025 liters to give us 0.152 moles per liter of nitric acid.